Hello friends, welcome back to our channel. So today we will see one more concept in compiler design, that is a category of top-down parser, that is recursive descent parser. So it is a recursive descent parser. So in our previous sessions we have seen the introduction to parser and what is the input of the parser and output of the parser, and what are the different categories or different types of parsers, top down and bottom up. And also we have seen, so in order to go with the top down parser, there should not be the left recursion for the grammar as well as the left factoring in the grammar. And if the grammar contains, that means the production rules contains any left recursion or the left factoring, first we have to eliminate that, because those left recursion and the left factoring are not suitable for top-down parsing. So here this is a category of a top-down parser. Top-down parser, and as the name itself indicates, it will be using of recursive procedures. So uses recursive procedures, either directly or indirectly, recursive procedures. So need not worry, I will take one example, the grammar, and let us design the parser. And then there will be no backtracking. So here, particularly in the top-down approach, so top-down parsing, there will be two methodologies, that is by using the backtracking and without using the backtracking. And this is a process where we are not using the backtracking. So no backtracking will be implemented or used, no backtracking will be there. No backtracking will be there, right? So this is the main thing of recursive descent parser. So before constructing this one, first let us see the rules which we have to follow in order to write this parser, recursive descent parser, for a given grammar. Okay, and one more thing, so there should not be a left recursion and a left factoring for the grammar. So no left recursions, no left recursion, and left factored grammar, left factored grammar, right? So then only we can easily implement this recursive descent parser, that means a top-down parsing, right? So here we will be taking one input and we are going to parse that input. So for that we are going to use some input pointer which points towards the starting position of the input and keeps on going. That particular pointer will be incremented by 1 until it reaches to the complete end of the particular string. So that we will see with an example. So before that we have to write down the rules for parsing using this recursive descent parser. So the first rule, rule 1. So if the input is a non-terminal, so here the production rules or the grammar will be in a combination of terminals and the non-terminals, right? So the first one, if the input is a non-terminal, if the input is a non-terminal, so that non-terminal should be expanded. So that's why, so here we have to write, so then write a procedure. So here if it is a non-terminal, then we have to write a procedure, right? So procedure or a subroutine, we can also call it as a subroutine, or we can also call it as a recursive function, okay? And the same function calling itself, either directly or indirectly, right? So that we have to do. So the first one, if input is a non-terminal, then we have to write the procedure. And then R2, rule 2. Now if the input is a terminal, if the input is terminal, what we have to do? So we have to compare that particular terminal with the input string, and if both are equal, then simply increment the input pointer to the forward level. So what we have to do? So first one, compare a terminal with a input symbol. If both are equal, okay, then increment input pointer. So we can forward it. Okay, we can forward it to the input pointer. Next, R3. What is the rule 3? So we have checked whether the input is, that means we have done when the input is non-terminal and when the input is a terminal. Now we have to see the next one, that is if any non-terminal is having multiple productions. Okay, if any production or a non-terminal will be having a multiple productions. So if any non-terminal having multiple productions, what we have to do? So we have to write the complete procedure, all the procedures, okay, I mean all the productions in the same procedure. Okay, so then write all the productions in single procedure. So we are writing some recursive procedures here, right? So while writing the recursive procedures, if any non-terminal points towards the multiple productions, then we have to write the complete all the production information in the single procedure. And one more thing, the last one, it doesn't have any main functions or any declarations. Okay, so no main and no declarations. So directly we can write down the procedure. Okay, so these are the rules for recursive descent parser. So we have to take one example and we can write down the procedure by using all these 4 rules, and then we have to take one input string which can be, whether that string can be parsed with the given grammar or not. Okay, that we'll see in just now, right? So let us take an example and let me explain about this process. So let us take an example. These are the given grammar, and here we are having a different non-terminals and also terminals, so production rules. So what is the first thing we have to check is whether this grammar is having any left recursions or left factoring. So obviously this grammar has not having, I mean this grammar was not having any left recursions and left factoring. So this is the grammar after eliminating the left recursion and left factoring. So first you check whether the taken grammar is having any left recursion or left factoring. And if you are not aware about that, how to eliminate the left recursion and left factoring, I'll post the video links in the description. So once go through that links and solve a few examples so that you will be getting a confident how to eliminate the left recursion and the left factoring, and what is the left fraction and left recursion and left factoring. Right now, see, this is the grammar we are taking. So without the left factoring and the left recursion. So this is suitable for top-down parsing. So always the top-down parsing should be started with the starting symbol. What is the starting symbol here? E. Okay, so we have to start with the starting symbol itself because it is a top-down parsing. And from the starting symbol, we have to expand the non-terminals until we get the terminals. And now, see, starting from this one, write down the procedure for each and every production here. Okay, so that we will be getting the number of procedures is equal to, I mean, how many number of procedures we have to write means in our grammar how many non-terminals, just count the number of non-terminals, so that many procedures will be getting. Okay, so you can observe here one example. So see, F tends to E or ID. So here this production, this non-terminal is having a two productions. So we have to write the complete thing. So the information regarding these two productions in a single procedure. Now we will go with the writing the procedures. So first one is a non-terminal. Okay, write down the procedure for E. Right. So procedure E, left parenthesis and right parenthesis, because usually we are representing any function by using the left parenthesis and right parenthesis. So I am also writing E, left parenthesis and right parenthesis, so that will be the procedure. Now see, the first one is a terminal. What we have to do if the input string is a terminal? What we have to do? So we have to write down the procedure. Simply call the procedure T. That's it. Next, E star. E star is also one more non-terminal. So write down here. So in order to represent a star, I will write down E star. E star, right? So two terminals. So this is the only procedure we have to write for production E. Okay, this is a procedure for production E because it is having only two non-terminals T and E. So if these are non-terminals, automatically we have to call the procedures. Now write down the procedure for the E star. Write down procedure E star. What we have to do? So we are having the input symbol, right? So that is a terminal. So write down if the input string, the input from the input string, whatever the input string is equal to the symbol plus. If it is equal to plus, what we have to do? So simply we have to write increment the input string, input pointer. So the input pointer should be incremented. After that, what is there here? Terminal. So if it is terminal, what we have to do? We have to call the procedure. So simply call the procedure T. And afterwards E star. Once again, this is also a terminal. So again, you can simply write E star. Call the procedure for E star. Okay, and close. Okay, whether this procedure has been completed? No, because so here E star is also pointing towards the epsilon. So that should also be written in this same procedure. So if input is plus, this one, else it will be epsilon. So you are taking it as E star, okay, having a two productions. One is plus T E star, another production is epsilon. So if the input symbol is not plus, automatically the input symbol will be epsilon. So here we can write it as else, simply return. So this is a procedure for E star. Hope you understood now, right? So here we are having a two different productions, and the complete two productions should be written in a single procedure. I have written in a single procedure. Now come to the next one, T. So we have to write down the procedure for T. So procedure T, what is that? The two are non-terminals, F and T star. So call the procedures F and T star. Right? So that is a T. And again, now there is a one more production T star. So write down the procedure for T star. Procedure for T star. So what is there? So there we are having some terminals. So again, write down the same procedure. If the input from the input string is equal to star, what we have to do? So simply increment the input from the rule 2. Okay, from the rule 2 we have written. And then if it is a terminal, what happens? Call. Again terminal, T star. Again call. So close it And you can observe here, similar to this E star, it is also having a one more epsilon, that means one more production. So we have to write down that production in the same procedure. So here we can write it as else. So as it is epsilon, we are writing it return. And if it is not an epsilon, again we have to write down the if or if else or else if ladder. Anything we can write it. So close this one. So this is the procedure of T star. And again we are having one more thing, that is a production for F. So we have to write down the production for F. So procedure F. So how we have to write? So first there is a terminal parenthesis. So simply write it as input is equal to left parenthesis. What we have to do? If it is a left parenthesis, so simply increment the input. Okay. Then again there is a terminal, non-terminal. So call the procedure. And again we are having one more terminal. So again write out if input is equal to right parenthesis, simply input plus plus. Okay, so the production ends here, so you can end it, and here also you can end it. Okay, and once again there is a terminal. So previously we are having some epsilon, but here we are having a terminal. Again we have to check here. So here this production ends, and here again we are checking if input. You can also write else or else if, whatever it may be. So I am writing here input is equal to id. If it is id, what I have to do? Again input plus plus. So close this procedure here. Close this procedure here. So this is the procedure for terminal. So how many procedures we are getting? So 1, 2, 3, 4 and 5. 5 procedures we have written. Now count the non-terminals in the production. So 1, 2, 3, 4 and 5. So here we are having some E, T, E star 3 and T star and F. So total 5 procedures, 5 non-terminals. So we have written some 5 procedures. And now let us check by taking one example. Let us take an example for id plus id and finally give the dollar, which means that end of the string. So first id. So remember, always the parser starts with the start symbol because it is a top-down parser. What is the start symbol? E. So from here it will be starting. Now immediately after this one it will execute the T. So it will check for the T, procedure T. Here it will comes. So F will be called. Now the procedure F will be called here. Now if input is equal to left parenthesis, but the input is id here. Initially the input is id. So this condition is false. Automatically it will comes out from this condition and it will check for this condition. If input is equal to id, yes, true. Then what we have to do? Input plus plus. So this will be incremented to this one. This will be incremented to this one. After ending this one, from where it will be called? Here. Okay, from here it was called. Now the control will come back to here. Now T star here. Input is equal to star, but here it is plus, not equal. So automatically it will comes to the else part, return. So from where this function has been come? From this one. So automatically the control will go back to this procedure T. So from where this procedure T has been called? From here it is called. So directly the function, the control will come to here. And E star. Now the E star will be taken. Now input is equal to plus. Yes, the input is equal to plus. What happens? Now it will be incremented. So the input will be incremented to this one. And T, it will be calling as T. Then control moves to here. F, again the control moves to here. So what happens? If input is equal to less than, no, false, comes here. Input is equal to id, true, input plus plus. So this input pointer will be pointing towards the dollar. So from where it has been called? From here, t star. So it will come here. So control, if input is equal to star, here dollar, false, return. It go back to the calling function. So t, it go back to the calling function. Okay, here. Next e star, it will be calling here itself. Input is equal to plus, but here it is a dollar. Automatically false, return. It go back to the main function. So it completes its procedure. So this is an input string which can be parsed by using this procedure. And you can also take the same with one more thing, id star id dollar. You can also take and check with this one whether our procedure has been correct or not. So id here also. So irrespective of the input string, always the procedure, the top down parsing will start from the starting symbol, that is e. So t, first the control will move towards t. F, it will move towards the f. So input is equal to less than, left parenthesis, false. So it comes out of the loop and it will check for id, yes. So now the input will be incremented, so it will be pointing towards the star. Now it is the end of the procedure, it will move to the calling function. So the control will move towards the t and it will start executing t star procedure. So it will go with the t star. If input is equal to star, yes, star. So input plus plus. So the input pointer will be pointing towards the next internal. Next f, procedure f, it goes to the procedure f. So input is equal to left parenthesis, no, false, moves towards the next part. Input is equal to id, true. So the input pointer will be pointing towards the next terminal or next symbol of the input string. So the procedure completed. So to where it will be going? So automatically it will go to the t star. Again t star. So again there is a recursive call. Okay. Now input is equal to star, but here input pointer is pointing towards the dollar. So false, else, return. So from where it will be getting? So it was getting from t, and from here t, it was called from this one, e star. E star, if input is equal to plus, but here it is a dollar. So automatically it will come out from the if condition and return. So it go back to the calling function, that is e, and that is the end of the procedure. So automatically this is also being parsed successfully. That means our procedure has been written perfectly. So always remember, this top down parsing will be starting from the starting terminal, okay, starting non-terminal of the production. And prerequisite, that means before starting this top down parsing, so first we have to check whether the grammar is having the left recursion and left factoring. If there, so we have to eliminate that left recursion and left factoring, then only we have to follow this procedure. Okay, we have to follow the 4 rules which I have given. If the first one is a non-terminal, write down the procedure. If the input symbol is a terminal, check the terminal with the input terminal, and if both are equal, then simply increment the input pointer. And the third rule, so if any non-terminal points towards the multiple productions, so simply write down the complete information about those productions in a single procedure. And the next one, the fourth one, is there will be no main function and no declaration part. So here we are not involved any main function, any declarations. Okay, if you want to write any main function, you can write down the main function, but you have to make a call for the procedure e, because it is a starting symbol. So you can write the main function, but in that we have to start the first symbol of the production, that is a grammar, right? So hope you understood this one, and if you have any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.